Hello. Today we're going to talk about absolute value inequalities with two variables. That sounds kind of scary, but basically we're looking at equations that would be something that we graph. So we have x and y in these. And so we want to look at how we find solutions to these. And again, they're inequalities, so we're going to have less than, greater than, less than, equal to, and greater than equal to in these particular types of problems. So let's look at a few examples. So the first example, which points are not a solution. So keyword not a solution of the inequality y is greater than or equal to the absolute value of x plus 3. And so here's our choices. We have -3, 0. We have -3, 6. And we have 0, 4. Okay, so how do we figure this out? Well, the best thing to do is to plug each one in to see what works and what doesn't. So remember, points are always x, y. So we're going to plug those into this inequality and see if they work or not. Again, we're trying to figure out which one does not work. So let's plug them in. So the first one, so we have 0 is greater than the absolute value of -3 plus 3. Now we have to remember, what does absolute value mean? Absolute value is the distance from 0. So distance means that it cannot be negative. So -3 is 3 spaces away from 0. So the absolute value of -3 is 3. 0 greater than or equal to 3 plus 3. Now, what is 3 plus 3? 3 plus 3 is 6. So now we have to evaluate. Is 0 bigger than or equal to 6? And we look at that and say, no, it is not. So in this case, this would be one of the things we're looking for. -3, 0 is not a solution in this inequality. So that's one of our answers. The only other thing is we have to know if there's any others. So let's take a look at the next one. Again, plugging them in just like we did before. So we have 6 greater than or equal to the absolute value of -3 plus 3. Absolute value of -3 is 3. So 3 plus 3 is 6. And again, we need to evaluate. Is 6 greater than or equal to 6? Well, 6 is not greater than 6, but we have the equal sign there. So is 6 equal to 6? Yes. So in this case, this would be a solution to that inequality. But again, we're looking for the ones that are not, so we're not going to pick that one. And let's try the last one just in case. And plug those in. So we have 4 is greater than or equal to the absolute value of 0 plus 3. The absolute value of 0 is 0. 0 plus 3 is 3. Let's evaluate. Is 4 greater than or equal to 3? Yes. So that would be a solution, but we're looking for the ones that are not. So the only thing that we're going to actually concern ourselves with accepting is the point -3, 0. That is not a solution in this inequality. All right, let's look at another example. It says to graph y is less than or equal to the absolute value of x. So you've learned how to graph things in the past, equations. You've also learned how to graph absolute value equations. And so in this case, absolute value equations, we know is going to kind of look like a V. So in this case, we can graph these things in various ways. We've learned some tricks too along the way. But remember, if all the tricks are just not coming to you, you can always make an XY chart to graph anything. Okay? The other thing is you can use Desmos. So let's take a look at this to graph this. So let me get us a graph here. If I know what the absolute value of x looks like, I'm going to graph that. It's going to be the same way to graph it as if it had equals. However, what are the differences? So the difference in graphing an inequality, one of the differences is if I have less than or greater than, then it's going to be a dotted line. If it's greater than equal to, less than equal to, it's going to be a solid line. And so in this case, because we have equal to, it's going to be a solid line. So if I were to graph y equals absolute value of x, it's going to look like this. Now, what is the added difference with an inequality? We have to figure out which side, where it's shaded. Because it's an inequality, it means that it has multiple solutions as opposed to just one. And so that means we need to shade what those solutions are. So the only way to really show how these work is to shade those solutions. So basically, we either have inside the V or outside the V to shade. We don't know which one. So how do we go about doing that? Well, what we are going to do is pick a point that is not on the line that we just drew. So we've graphed what it looks like when it says equals. What we need to do is pick a point that's not on the line. I don't care what point it is, doesn't matter, just pick one. So in this case, I could pick up this point here, which let's say it's at 0, 2. And we'll go with that and pick that to plug in, just like we did in the last example, plug it in for x and y. So we have 2 is less than or equal to the absolute value of 0. So we have 2 is less than or equal to 0. Is that true or is that false? Is 2 smaller than 0? The answer is that it's not. So what that means is because that point doesn't work, we're going to shade the other side. So basically everything out here is what is shaded. So in order to actually graph this particular inequality, what we are going to see is this. So the solid line and then the shading where it's appropriate. All right, let's look at another example. So we're going to graph y is less than absolute value of x plus 3. Okay, same thing. Graph it. We can make an XY chart to graph it. Whatever works. In this case, if we use our transformations, we have a plus 3 on the inside, so connected to the x. And so the plus 3 means that it's going to move left or right. Remember, it's backwards on this one. So even though it has a plus 3, we actually move it left 3 spaces. So we take our parent graph and move it 3 spaces to the left. It's going to look like this. However, what do we notice? Well, it's a less than. So this needs to be a dotted line. Okay. So not solid, dotted. So it's a dotted line. Now, we have to figure out where to shade it. So again, we pick a point not on the line. I'm going to pick 0, 0. If that's always available, I usually pick it. It's really nice. So if I pick the point 0, 0, we're going to plug it in for x and y into the inequality. So we have 0 is less than the absolute value of 0 plus 3. We have 0 is less than the absolute value of 3. The absolute value of 3 is 3. 0 is less than 3. Is that true Yes, it is. So because we picked 0, 0, that's right here, it is true. That's the part that we shade. So we're on the outside of this. All right, one last example to go over with you. Graph absolute value of x plus y greater than or equal to 0. So this one looks a little bit different. We don't have it in the y by itself formatting, but we can make it that way if that makes it easier when you're graphing to know what this is going to look like. So if I subtract the absolute value of x to both sides, then I would have y is greater than or equal to negative absolute value of x plus 0. You can have the plus 0 or not. Totally up to you. Again, now we need to graph this. And if we want to use our transformations, because that makes it easier, notice it's absolute value of x, but we have a negative in the front. When the negative's in front of the entire function, then that means that it's a reflection over the x-axis. And so whereas this would be a v, now it needs to go over the x-axis, and so it's going to look upside down. Right here, we have greater than or equal to, so that means that we're going to have a solid line. And so here is our graphing of that so far. And now we need to, again, shade, see which side to shade. So again, pick a point. I'm going to pick the point 2, 0 and plug it in. So we can even plug it into the very original if you like. So we would have the absolute value of 2 plus 0 greater than or equal to 0. Absolute value of 2 is 2. 2 plus 0. And then 2 plus 0 is 2. Is 2 greater than or equal to 0? The answer is yes. The point 2, 0 is out here. So that's the side that we shade. So that's all the examples for this one. Again, as you work through your lesson, if you have any questions, be sure to ask your teacher. Thanks. Have a great day.